Hello everybody, welcome to this video about grouping multiplication of numbers with two digits in base 10 by using base 10 blocks. So the problem that we have today is 13 times 12. And the context of that would be that word grouping any combination of 13 and 12. So examples could be you have 13 students with 12 assignments each, or 12 students with 13 assignments each, showing that commutative property. And this really can work with any real-life application of money or any item quantity that you are trying to group, with the grand total being the question: how many total assignments do I need, depending on what's in that last slot, assignments. So looking at it with base 10 blocks, we have the base 10 block of 10 by 10 showing 100 with dimensions. So we do the rows and columns here. And then we have base 10 blocks showing a 10 or a 10 by 1. And then we have our unit digit that we'll need for today. So, try to get it in focus here. Alright, so what I have here is a chart showing each number that's being multiplied. So we have 13 up above, represented as the addition of 10 plus 1 plus 1 plus 1. And then in my row here, I have the second number of 12, 10 plus 1 plus 1. So all I'm going to do is represent it in terms of area or dimensions, or students would know which blocks they would need by doing the rows and the columns. So the question would state, if we're doing 10 by 10, which block has 10 by 10? So that would be our first 100 flat 10 block here, showing a 10 by 10, and that would be the first matching step. And really, the nice part about this is no matter which direction you go, if I start here or here, it's going to get me the same answer, and that's something that I would go over with students for sure. So going next, I believe I went 10 by 10, so I'll continue to go to the right. I have 1 by 10. So where do I have a 1 by 10? That would be the 10 block. And then you can see by inductive reasoning patterns that I have two others. Okay, so this is where I do all of these by this first one giving me my first row. Very similar to matrix multiplication here. I then will go to my next row here. So I have 10 by, not 10 again, but down here to the first I have 10 by 1. So I did 1 by 10, so I'd be asking the same question, leading to some good questions, giving me here. And then going around here, I have 1 by 1, 1 by 1, and 1 by 1, showing the same thing here. Alright, going to my last row, 10 by 1 still gets me 10. And then I have the same thing here with the 1 by 1s that I'm going to fill in here. So now we have all of our groupings done by matching rows and columns in this table. So now we actually have to find the right answer by really adding up the total that we have. So I would do it in terms of quantity. So we just ask ourselves the question, how many of the 100 blocks did I use? We can record 1. How many of the 10 blocks did I use? So I can see 1, 2, 3, 4, 5. How many of the 1s? I used 6. And then showing 13 by 12 would state, if you used 100 block, there's 100 spaces. 5 10 blocks, we used 50 total. And 6 1s, we used 6 total. Adding those up, giving us a total of 156, shown here with 100, 10, 20, 30, 40, 50, 150, and 156. So there you go. There is a video showing base 10 blocks with numbers of two digits in multiplication.